So welcome back, and today we're going to learn about how to reverse a linked list. Alright, so first, before we do some code here, let's look at it visually, and let's define what a linked list is. So a linked list is simply a structure that has a pointer to another version of that same structure, another instance, and so forth until you hit the end of that list. And so visually, we would say something like this. We would say this node has number 1 in it, this entry or node number 2 in it, this entry or node has number 3, and then the last node points to null. And structurally, what we would say, for example, you would have a struct of underscore what is called entry, and we'll have an int value, and then we'll have a struct underscore entry pointer p next. And that is essentially what a linked list looks like visually. You have as a structure, you would have an entry, some entry that has some data in it, some values, and then you have another pointer that points to the same type of structure that would have the same values. And so you would walk that list of all of your data. And visually, we usually represent it like this here. Now I will show you another board up here. Let me draw this. Just take me out. All right, so I've drawn this here, and this is your memory, right? So you have, we'll say these are all in hex. So this is 100 hex, location 0, and each location is 4 bytes. So 0, 4, 8, 12, wrap around to 16. 16, 16, 4, 16, 8, 16, 12, 32, and so forth. And so this is your memory layout. So whenever we have a linked list, we essentially have something that points to that linked list. For example, we'll have the head, so a p head, right? And p head itself is in memory somewhere. So we'll say at 160 hex is p head. And p head contains the address of the first entry in the list. And we'll say the first entry of the list is at 120. So at 120, we have the value 1, and the next value has a pointer to the next location. And we'll say that's at 158. So at 158, that's this right here, we now have the value 2. And then this entry points to the next list entry, which we'll say is at 114. So now we have the value 3 and then 0. So this is what it actually would look like in your memory. In your memory, you would have something on a stack or somewhere, or here we're just saying it's at 160, but essentially it'd probably be in your stack, so it probably wouldn't be in the same vicinity as all this other memory, but it'll hold the pointer to the first element here. And then that points to the next element, this location, the next pointer, and then that holds data, points to the next location, points to the next location, which is 0, and then it ends. So this is graphically how it looks, and this is how it will look in memory. It's essentially what we were looking at in memory. So if we did an ampersand of the head, we would get 160, for example. And so this is essentially what we're looking at. And we want to reverse this linked list, which means we want head to point to this location, and we want 120 or 158 to point to 120, so forth. So what we want to do is reverse this linked list. So in the end, what we would end up having, where we currently have this, so instead of 160 being pointing at 120, we would have 160 pointing at 114. Put parentheses there, right? And then 114, instead of pointing at 0, would end up pointing back to 158. And then this, instead of pointing to 114, would point to 120. Point over to here. And this, instead of pointing over to 158, would be 0. In parentheses, right? So currently, we have this going on. And what we want is to have this going on. Well, sorry. That should be pointing back to that one. That points to that one. That points to that one. So that's pretty much what we're going to end up doing in this video here, is showing you how to reverse this. So first, I want to say a common mistake that a lot of people do when they try to reverse a linked list is they overreach. And so what I mean by that is they're doing, as soon as they go into the function, the first thing they do is grab next to next to next to next. They're overreaching, they're trying to work over here. And so they end up tailoring their function to work only with a certain number of elements. And the problem is that they don't need to do that. They need to just think where I'm at currently and what I can do here. They only need to work in this area and then work on this area and then work on this area. They need to work on one area at a time. So the first thing you look at here is, well, there's an invisible previous here, right? So when I come in, my previous points to 0. That's my invisible previous. So what I want to do is point next to previous. But if I point next to previous, I'm going to lose 2. So what I got to do? Well, I got to make sure I don't lose 2. So I have a temp, point to 2. Then I point the previous. Okay, so now what I have is I have head, I have previous, and I have a temp. I think I'm pretty much done for this part of the loop. So I need to move on to the next loop. And so whenever I do that, what I want is change head, right? I think that head should point to temp, but if I do that, I'm going to lose head. So previous is already pointed to, so I don't lose it as long as I'm tracking that location, this one. So previous is now 1. And I still have 0, I still have 1. I'm fine. Okay, now head goes to temp. Okay, now I've got this list, I've got my previous, just like I had before. So it was the first thing I did last time. So now I'm starting all over again. This is pretty much where I was beginning, because I really don't care where temp's pointing. So what I have to do again? Well, I gotta save my next here, so save temp. Then what I gotta do? Well, I gotta point this back to previous. So now I'm at the same place again. You know, this is now, I can't lose that, so previous, previous is now this. Head is now pointing to temp. Loop around again. I'm back where I started again. So now, I don't really care that's null or not. That's now temp. Temp is null. Now, now that I've saved temp, point this back to previous. Now, previous points to this, and head points to null. Now if I loop around, I can check head. If head's null, I'm done. And my new head is previous. So I can point head to previous or return previous. So that's pretty much how you end up reversing a linked list. And we're going to go into that graphically, or code-wise in a minute. But I do want to point out there is an optimization. Well, not really a optimization, just something I can show you that you can do it in 2 variables instead of 3. And we'll show you that in a minute after we do the code for this. All right, so here we go. I've already created this template here, which essentially will create the list, it'll display a list, and then it'll free the list. And so we have this little loop going here. So what we want to do is display it, reverse it, and redisplay it, and make sure it's reversing. So the first thing we could do is I've set this assembly program up to reverse the linked list. So we're going to pass in the linked list to the head, and then we'll reverse it. And so we will take a look at that first. If you want to see the C version, you'll have to skip ahead to the portion of the video that I show below. So this is the assembly version. So the first thing we're going to do here, so when we come in, essentially RCX will have the head, right? So the first thing we want to do is set up our, essentially RDX will be our previous, right? And so the very bottom here, we're going to say move REX RDX, because REX is the return value. So return the new head. Now the next thing we want to do is we want to compare, because this is going to be our reverse loop now. Reverse loop. And in our reverse loop, we will, let me push this out a little bit so that the reverse loop. So in our reverse loop, we will essentially first just check if head's null. And we will do that by comparing. Actually, we can do it with a test RCX. If this is 0 at exit loop. Let me put a little at sign there too. So we're going to do exit loop here. And then of course here we will say jump back up to reverse loop. So at this point, if we have a null list, we will return null, right? So remember what we said the first thing we wanted to do? The first thing we wanted to do was we wanted to save the next value, right? So we need a temp value. Our temp is going to be R8. So move R8, and we will say, I want to say this here. So no, I didn't want to do that. Sometimes I hate these editors. That P next of RCX into R8. So the first thing I want to do is save node to the next, right? So what's the second thing I want to do? Second thing I want to do is we want to point node to the next to our previous. Point node to the P next to previous. Oops, I didn't mean to put R8 there. I should put RDX. Right. Now that we've done that, the next thing I want to do is move previous forward, right? So previous, RDX, now RCX. So previous is equal to the head. Next thing I want to do is move our head. Head is equal to, go to the P next. So is there anything else that we need to do? So now we're going to loop around, see if the next is 0. If it is, we're going to loop out and we're going to return head. Seems like this should be pretty much it. So we can give this all right, so I do have to do this here. So I did run it and I found I missed the return the head. So yeah, now that I'm returning the head, as you can see, I've defined it up here as well. And so now we will be able to build it and then we'll just run it here. So as we can see, it does reverse the linked list. So, as I promised, you know, this is the assembly run. Make another run down here for the C version of it. And I'll just remove that. Yes, and this time we'll remember not to, or make sure we will, you know, actually update this one. Yeah, we're gonna update it. Okay, so we'll print up here, printf, assembly version, with the reverse, and then the C version will be down here. So as promised, we will do the C version now. So as I was saying, a lot of people end up trying to, I see a lot of people doing like p head, if p head equals null, return, p head to the next is null, return, blah, 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 so again, like I've said before, we're not going to do that. We're going to set p node is equal to null, and then we're just going to go right into the while loop, because the while loop won't even work if head's null, and then we'll just return p node, because p node will be the new location. Again, that's the previous. I can name it previous, and we also have the p temp. So remember, the first thing we do here is we want to save p head to the p next. Save that. P head to the p next is equal to the previous, right? And then we want to take the previous and move it up to head, and take head, move it up to p temp, and that's pretty much it. So see if this one works or not, and it looks like it did work. So that is pretty much it. Yeah, I did have a problem here when I first compiled this, just because I forgot to set the return to the head. So, but yeah, just make sure you update the head when you're done. So as you can see, reversing a linked list is actually, where is it here? Here it is. Reverse here. So it's actually just a few lines of code. So now we're going to move back on, and we're going to talk about that trick I was talking to you about before. So let's go back and draw our linked list again. So we have 1, it points to the 2, points to the 3, and it points to the null location. Now, as I said before, there was a trick. Kind of stupid trick, but nonetheless. If you wanted to, so you have p head, and p head points to 1 here. Now, we needed 3 variables before, right? Well, what if we could eliminate 1? And so instead of having this temp variable over here, now we have p head, and we have p new head. And we point p new head to null. So what we can do, there's a trick where you can swap 2 values by doing 2 operations in inverse. And now for XOR, for example, is the inverse of itself. So if we do, for example, A XOR is equal to B, B XOR is equal to A XOR is equal to B, we essentially swap those numbers. And we can actually prove it here, because let's say we have 0, 0, 1, 1 for A. And then over here we have 1, 0, then we have 1, 0. So in this case here, we have, we should have all of the combinations where we have a 0 on this side, a 1 on this side, a 0 on this side, a 0 on this side, a 1 on this side, a 1 on this side, a 1 on this side, 0 on this side. So our first operation, you remember, is A XOR B. So A XOR B. So B remains the same. A, 0 and 1 is 1, 0, 0, 0, 1, 1, 0, 1, 0, 1. Now we do the same thing again to B. A remains the same, 1, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 0, 1. So as you can see, B actually contains the original value of A now. Now we do our last XOR, and we'll do A, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And now A contains the value of B. And so those are all the combinations. And so as you can see, by doing these three operations with two variables, you can completely swap things. Now, but the problem with these pointers is in C's, they're not going to let you do that. So you'd have to do a ton of typecasting to do this. But you could essentially do it this way. So essentially, the first thing you want to do is point this to there. And so by doing XOR of P head and P head to the next, we would end up pointing this up to here and pointing this down to here. We do one more XOR of P head and new head. And now P head points to here, head points to here. Now you're doing the loop. It's just two sets of swaps. Right, so now if I swap this again, I point this back over to 1, and P head points to here. Swap these two, this points to here, this points to here, and then so forth, right? At the end here, we do this to this, and so this is now pointing backwards to this, and new head's pointing to 0. We do the swap here. P head points to 0, and then this one points to 3. And so essentially by doing two sets of these XOR operations, you can reverse the linked list without the third variable. And to make things a little bit more interesting, if you went and did a doubly linked list, you just need the head. Because all you need to do is swap the next and the previous at the same time, and then go previous until you reach null. So yeah, essentially if you had doubly linked list, point to 0, this one points to this one, this one points to this one, this points to this one, this points to this one. Essentially all you have to do is swap the previous to the next, and then the next point to null, the previous point back here, and then you move to previous. Do the same thing, right? The previous will then point over here, the next will then point back here, and then all you do is you go previous and you're back here, right? So you can do it with one variable and one swap if you had a doubly linked list. But essentially, a stupid trick. The compilers aren't going to like it because you have to typecast things, so it's not really recommended to use this with pointers. It's easier to do in assembly, but as you saw, again, there's really only three operations that need to occur here. And for assembly, the whole thing was pretty much kept in register to begin with, so you don't really save in too much. It's just a neat trick. So that is how you reverse linked list.